Welcome to SS2 Computer Science, Term 3, Week 15. Artificial intelligence, AI, is one of the most transformative technologies of our time. It is reshaping industries, economies, and everyday life, from the recommendations on your phone to self-driving cars to medical diagnosis systems. Understanding the basics of AI and machine learning is essential for any student of computer science in the 21st century. By the end of this lesson, you will define AI and its subfields, explain what machine learning is and how it works, describe the main types of machine learning, identify real-world applications, understand ethical considerations, and answer WAEC questions on AI and machine learning. Let us begin. What is artificial intelligence, AI? AI is the simulation of human intelligence processes by computer systems, including learning, acquiring information and rules, reasoning, using rules to reach conclusions, problem-solving, perception, understanding language, images, speech, natural language understanding, decision-making. A brief history of AI, 1950, Alan Turing proposes the Turing test, a test of whether a machine can exhibit intelligent behavior indistinguishable from a human. 1956, John McCarthy coins the term artificial intelligence at the Dartmouth Conference, considered the birth of AI as a field. 1960s, 70s, early symbolic AI expert systems using hand-coded rules. 1980s, first AI winter, funding cuts after limitations became apparent. 1990s, machine learning begins to dominate. 1997, IBM's Deep Blue beats world chess champion Garry Kasparov. 2006, Geoffrey Hinton and colleagues revive neural networks, start of the deep learning era. 2012, AlexNet wins ImageNet competition using deep convolutional neural networks, deep learning revolution begins. 2016, Google's AlphaGo beats world Go champion, previously thought impossible for AI. 2020 plus, large language models, LLMs, GPT-3/4, Claude, Gemini, can write, code, and reason. AI subfields, machine learning, ML systems that learn from data. Deep learning, DL subset of ML using neural networks with many layers. Natural language processing, NLP AI that understands and generates human language. Computer vision, AI that understands images and video. Robotics, AI-powered physical systems. Expert systems, rule-based AI systems that encode domain expertise. What is machine learning, ML? Machine learning is a subset of AI where systems learn from data to improve performance on a task without being explicitly programmed with rules. Traditional programming, programmer writes rules, computer applies rules to data output. Machine learning, data plus desired output, machine learns rules applied to new data output. Types of machine learning, supervised learning, the algorithm learns from label training data, each example includes the input and the correct output / label, the goal, learn a function that maps inputs to correct outputs, examples, email spam detection, emails labeled spam or not spam, the algorithm learns which features indicate spam, image classification, images labeled with categories, cat, dog, car. The algorithm learns to classify new images, house price prediction, historical. House data with prices, algorithm learns to predict prices, medical diagnosis, symptoms labeled with diagnoses, algorithms learn to diagnose. Algorithm examples, linear regression, predicting continuous values, logistic regression, classification, decision trees, random forest, support vector machines, SVM, k-nearest neighbors, KNN. Unsupervised learning, no labels provided, the algorithm finds structure in unlabeled data, examples, customer segmentation, find groups of similar customers without predefined categories, anomaly detection, find unusual transactions in a bank account, recommendation systems, find similar items or users. Algorithm examples, k-means clustering, principal component analysis, PCA, autoencoders. Reinforcement learning, an agent learns by interacting with an environment, the agent receives rewards for good actions and penalties for bad ones, learns to maximize cumulative reward. Examples: game playing, AlphaGo, OpenAI 5 playing Dota 2, robotics, robot learning to walk, self-driving cars learning driving policies. Neural networks, inspired by the human brain's structure, billions of neurons connected by synapses. Artificial neural network, ANN, a network of artificial neurons, nodes, organized in layers. Layers, input layer, receives the raw data features. Hidden layers, intermediate layers that learn representations of the data. Output layer, produces the prediction or classification. Each connection between neurons has a weight learned during training. How a neuron works: receives inputs, multiplies each by its weight, sums them, applies an activation function, e.g. real U, sigmoid, outputs the result. Training a neural network, forward pass, data flows through the network, a prediction is made. Loss function, measures how wrong the prediction is, e.g. mean squared error for regression, cross-entropy for classification. Backpropagation, the error is propagated backwards through the network, weights are adjusted to reduce the error. Gradient descent, the optimization algorithm that adjusts weight step by step to minimize the loss. Learning rate, how big each step is. This process repeats for many iterations, epochs, over the training data. Deep learning, neural networks with many hidden layers, deep equals many layers, can learn complex hierarchical representations from raw data, revolutionized image recognition, speech recognition, natural language processing, medical imaging. Convolutional neural networks, CNN, specialized for image analysis, detect edges, textures, shapes at different scales, used in face recognition, medical imaging, self-driving cars. Recurrent neural networks, RNN, specialized for sequential data, text, speech, time series, maintain memory of previous inputs. Large language models, LLMs, GPT-4, Claude, Gemini, transformer-based models trained on vast amounts of text, can generate coherent text, answer questions, write code, translate languages. Applications of AI and machine learning in everyday life and Nigeria. Recommendation systems, YouTube, Netflix, and Spotify suggest content based on ML models learning your preferences. Search engines, Google uses ML to rank billions of web pages and understand natural language queries. Virtual assistants, Siri, Alexa, Google Assistant, speech recognition, NLP, and conversational AI. Healthcare, AI diagnostic systems detect cancer in medical images with accuracy comparable to specialists, disease surveillance and prediction, COVID-19 pandemic, drug discovery, DeepMind's AlphaFold solved protein structure prediction, transforming drug development. Agriculture in Nigeria, AI-powered crop disease detection apps, e.g. Plant Village, allow farmers to photograph their crops and get diagnosis via ML. Precision agriculture using satellite and drone imagery with ML. Finance, fraud detection, ML systems detect unusual transactions in real time. Credit scoring for microfinance and mobile lending, Cowrywise, Piggyvest backend systems. Natural language processing for Nigerian languages, research on developing NLP models for Yoruba, Igbo, Hausa, making AI accessible to Nigerians in their local languages. Self-driving vehicles, Tesla Autopilot, Waymo uses deep learning and computer vision. Ethical considerations in AI, bias and fairness, AI systems trained on biased data produce biased decisions. Examples: facial recognition systems less accurate for dark-skinned faces, loan approval algorithms discriminating against certain demographics. Privacy, AI systems process vast personal data, risks of surveillance, facial recognition by governments. Job displacement, automation of routine tasks by AI may displace workers, requires reskilling. Accountability, when an AI makes a wrong decision, who is responsible? Deepfakes, AI-generated fake videos and audio can spread misinformation. AI and weapons, autonomous weapon systems raise serious ethical questions. Nigeria and AI, NERA, Nigerian Internet Registration Association, NITE's AI strategies, growing startup ecosystem leveraging ML, Flutterwave's fraud detection, Helium Health's medical AI. Key points: AI, simulation of human intelligence by machines. ML, learning from data without explicit programming, 3 types: supervised, unsupervised, reinforcement learning. Supervised learning learns from labeled data, classification, spam/not spam, and regression, price prediction. Unsupervised learning finds structure in unlabeled data, clustering, anomaly detection. Reinforcement learning learns through reward and penalty, games, robotics. Neural networks, layers of artificial neurons, input hidden output, weights adjusted through backpropagation and gradient descent. Deep learning, many hidden layers, CNNs for images, INNs for sequences, LLMs for language, GPT for Claude, Gemini. Training, forward pass calculate loss backpropagation update weights, repeat until convergence. Applications, recommendations, Netflix, YouTube, search engines, virtual assistants, healthcare AI, agricultural disease detection, fraud detection, self-driving cars. Ethics, bias, privacy, job displacement, accountability, deepfakes. Nigerian AI context, Yoruba, Igbo, Hausa NLP research, agritech ML apps, fintech fraud detection. WAEC questions, define AI and ML, distinguish supervised from unsupervised learning, explain neural network layers, describe an application of ML, state ethical issues with AI, explain the difference between AI, ML, and deep learning.